Guys, is attendance enabled? Mark the attendance, guys. So we'll wait for 1 more minute. Okay, so I think we can start. There are 50, more than 50 people now. Okay. One of the programs that we have already decided to discuss is the linked list program. So that we are going to do. It might take what 15, 20 minutes maybe. Um, but we'll probably need one more program to discuss. So keep this in your mind that we'll need to discuss something more. Before that, we'll have some mock lab, right? Like a 15-minute lab. I'll just give you an addition program, add two numbers kind of thing. This is a mock lab, a 15-minute lab. So you'll get 15 minutes of time on Hacker Earth. We have to decide upon a time. Let us just make it 10 p.m. I think 10 p.m. is good enough, right? People would have had dinner by that time. So 10 to 10:15, you will get some time just to write an addition program. This I would have given you hello world, but hello world will not. It doesn't make any sense to give any test cases with hello world, right? So I'll just write an addition. I'll just ask you guys to put up an addition program, and because then I can give some test cases. So that is the idea. Just this is for those people who do not understand how Hacker Earth works. Um, Although I assume that you guys have already used it, but still, from my side, I'm giving you like one more opportunity to get yourself accustomed to the. Uh, okay, so there is some contest. Ah, so is it? I mean, it's like this, right? I don't. If you guys already know how to use Hacker Earth, then this mock lab is not required. Okay. Um, are there any people out there who have not used Hacker Earth before? They can tell me. I can probably just create a small lab, mock lab for them. But if all of you, because from your seniors, uh, I got the feedback that all of you are supposed to participate in these contests. So so I think all of you already know how to use Hacker Earth, right? So what do you guys feel? I mean, that the only point of that mock lab was to give you an idea of the platform, but maybe you actually know the platform better than me. So if you don't want, we can have the lab directly tomorrow at 4:15. Okay. So uh, is there anyone who has not used Hacker Earth before? Or maybe, as I said, I'll keep it at 9 p.m. Because I also have to check out this invitation option. Okay, invite only option. So I have to invite you guys with your email addresses. So I will create a mock lab, 15-minute lab. It's not necessary for you to take it. That is the idea, right? Some of you who would like to do some practice, some of you who have not really taken these coding competitions seriously, they can probably just come and have a look and get accustomed for tomorrow. But at 9 p.m., I'll just put up a small 15-minute lab. It is not necessary, as I said. Um, this is mostly to give you an idea of the platform. So at 9 p.m., I will create a small 15-minute problem. Okay, and at least make sure that you get invited to that lab, that mock lab. Okay, if you get the invitation, it's fine, right? I mean, then everything works. But if you do not get an invitation for the lab, then you have to contact me, okay? Because then uh, you will not be able to participate in the lab tomorrow. And this is the last time I am requesting you all. If you have not created your accounts on Hacker Earth using your institute email, please do it as soon as possible, because the invitation will only go to your official emails. Okay, it will not go to your personal emails. So please make sure that you have registered using your official email. Okay, so let's start, guys. 2 hour only. Kirti. The exactly the same that we had last time. 4:15 to 6:15, 2 hour lab without any demo. Um, and and with the sword of moss hanging over your head. Okay. I'll just download all your submissions on some weekend, and then I'll send it to Moss to generate a report. I mean, I'll have to actually take help from the TAs as well, because I alone will probably not be able to uh, analyze the whole report. So I'll have to find out some weekend where I will sit with your TAs, and we'll check the Moss results. Anyhow, so let's yeah, you guys can see my screen, the VM.
Yes, sir.
Good. Okay. So this is basically the linked list program. So how many lines are there? Let me just check out. 177. Okay. Hmm. So let us, as I said, right, let us start reading from main. Okay. So before that, just a quick revision of linked lists in general. So linked list, as you guys I have already studied, it is basically a data structure. It is a data structure which allows you to create nodes. Okay. Again, let me use the term. The term node is the common term that we all use, but it is not necessary that when you create a structure, you call it exactly node, right? You can call it anything you want. It's just that this is common terminology to call it as node. So that is why I'm going to use the term node. Node here means a particular structure template. Okay. And we are going to create variables of type node. In fact, let me just start from there. This is node.h that I am including here. So this is the simple node. Okay. And by the way, this is another way to write type def. Okay. So I told you, right, what basically type def is used in such a way. Whatever is there between type def and the last token. Um, so this last token becomes the alias for this. So this is another way, a shortcut way to to declare these type def things, right? You can actually uh, write node here itself. Now it might be a bit confusing, because usually this place, if you do not type def here, this will be considered as a variable, a structure variable. But because I have put type def, now it is not a structure variable. It is basically the alias for struct node. Okay. So don't be confused with this notation. If you do not have type def written here, then whatever you write after this closing parenthesis, they are basically structure variables of this particular structure type. But if you type def here, then this is an alias. Node is now an alias for struct node. Okay. So don't be um, don't get confused between these two. Okay, let's start from here. So this part you have already seen in the array operations part. Basically, this is just a system command is essentially a system function call essentially calls up a system command. Okay. So this is actually platform dependent. Okay. um, if you are on, let us say, a Windows machine. mm, Again, I have not tried it, but probably it should be CLS instead of clear. Okay. On Windows, the command prompt command for clearing the screen is CLS and not clear. So I really don't know whether in fact, I don't know whether system function itself is present in any Microsoft based C programming environment. But that this is the idea, that this is just a command. I'm just saying, please run this command from the background. And what is the background? Basically, Here it is bash where we are going to execute it. Okay, so this is just some messages. Um, this is this part, right, from here line. Let me just also. So from line number 141 to 151, this part is basically supposed to print your linked list, whatever is currently the state of your linked list. This code is just doing that. Now if you remember, the first element of the linked list is basically head, right? And that is what this is what it's saying. That says head double equal to null. This means that we are essentially having no nodes right now in this linked list. Otherwise, what is it going to do? This is this 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 particular piece of code, right? This is actually also known as traversing a linked list. Now if you remember, how do you traverse an array? The way to traverse an array is that you write a loop, something like I equal to 0, I less than size, I plus plus, and then you basically use up arri, right? So this is the common way to traverse an array. Traversing means you go from the first element to the last element. So when you want to traverse a linked list, the way to do that is this. You basically start with a temporary pointer. The temporary pointer points to head. Okay, and then you basically keep on doing this temp equal to temp uh, arrow next. And again, just to give you another recap, the arrow operator will actually point to, so this is like this. It is equivalent to saying asterisk ptr in parenthesis dot the member, right? So basically this expression is equivalent to writing asterisk temp in parenthesis dot next, right? So this is also known as the pointer to member variable operator. Okay, so this is the idea that in a loop you do something like this. You basically keep on doing temp equal to temp arrow next, and until this thing actually becomes null. This is the idea. When it becomes null, then you have to stop, right? If you remember the last node in the linked list, the next part of that node is set to null. This is how we say that the linked list terminates here. So then this is just a printf statement, which is basically printing the value, the actual value stored in that node, in that structure variable node, and this is just printf. Okay. So is this part clear? How do you traverse a linked list? The idea is you start with the head, and then over a you basically in each iteration, what you do is you keep on going to the next value, right? Next, using the next thing, and then at some point of time, this next will become null, right? The node you are going to point to becomes null, and this is where you stop. Okay, so this is the overall idea. So any queries on this part, traversing a linked list? No, it's very simple. But basically, this is what. So this is equivalent to int I equal to I equal to 0, I less than size, I plus plus. So it's just that we don't know the size, so we do it something like this. Okay. So then there are some options here. What operation would you like to do? We said there are two operations: insertion and deletion. So this is just the same thing. There are two functions here, one for insert, one for delete. And then I think we have discussed this clean stdin function already. So because I need to take a character input, yes or no, I have to put that clean stdin, so that when we get this character, we get its value in choice. Okay, so this loop is very simple. Now there are two functions here, insert and delete. Now if I remember, there was something missing in this code that I had changed on the Google Drive itself. I will see. Maybe there was some bug in this code. Anyhow, let's start with insertion, guys. So what are the things that I need for insertion? The first thing is insertion in linked list are usually done in two ways. Okay, if the linked list is empty, and not just empty, you can also have it when the linked list is actually not empty. But basically, what I'm trying to say is you can either insert a node at the head of the linked list, right? So the first node of the linked list can be changed. That is one option. Another option, and this is why we are doing this, because usually we do not maintain the indices of a particular node in a linked list. Okay, linked list, unlike an array, is not a random access data structure. What do I mean by random access? With arrays, if I want to access the ith index of the array, I can do that straight away by saying arri, right? But in a linked list, I cannot do something like this, right? I have to start from the head, and then I have to keep on moving forward. Okay. So usually when we talk about insertion in a linked list, we don't talk in terms of indices, we talk in terms of values. So this is why the second option is you can insert a value after a particular value. Okay, so why is it? Because usually we don't keep track of the length of the linked list, and even if we do keep track, we cannot actually access a particular node directly. So this is the idea that you usually do at the time of insertion, people actually ask you, where to insert, as in after which node should I insert it. So there are two ways in which insertion can happen, either at the beginning, because if you're doing it at the beginning, there is really no node before that node, or if you want to insert it anywhere else, you have to tell me the node that is immediately preceding the wanted node. So I just take up users preferences. Which of the two options would you like? This is just some validation. Now at this point of time, what I'm going to do is something like this. Yeah, and I also take the value to be inserted. So at this point of time, what I have to do is something like this. I first have to traverse the linked list in order to find that previous node, right? Node as in previous node, as in the node after which I have to insert the new value. And how do I do that? It is exactly the same way as we traverse the array. uh, for a particular value, what do? You do for I equal to 0, I less than size, I plus plus, and then within the parenthesis, if arr I is something like this, then you do something, right? So the same thing is there with linked list. This loop, okay, we saw a form of this loop where we were checking when temp is equal to null, we'll stop. The same thing is here. I start with temp being pointing to head, and then here I also have an additional condition, right? That please continue this loop, this temp equal to temp next. Please continue this till you reach op2. And what is op2? Op2 is the yeah. So op2 is basically the value after which you have to insert your new value. So where will this loop end? This loop will end when temp is pointing to that particular node where I want to make the insertion. I mean, after which I want to do the insertion. So this is basically the node that is immediately preceding the node to which, after which I want to add a new node. So now what does this part say? So basically it is possible that the value after which you are asking me to insert this new value may not be there at all in the linked list. So in that case, it will keep on going till the end, right? And then this particular condition becomes false, right? That now your temp itself has become null. So then there are two possibilities. When this loop ends, either temp is null, it means that we have reached the end of the linked list. So in this case, I simply print out a message which says this particular value, the previous value, by the way, is not present in the linked list at all. Or what I'll do is something like this. I have created another pointer called after node. After node, as in this is what I'm trying to say, that I should insert this node after this node, right? So the new node has to come after the after node. Then what am I doing? So I'm using malloc, by the way, and this is something that that I told you when we were studying malloc, that while with arrays you may not have actually understood the importance of dynamic memory allocation. You might say that modern compilers anyhow allow us to create arrays of dynamic sizes. So what is the use of malloc? So now you can see what is the use of malloc. You can actually allocate memory on the fly using malloc. So here I am now creating a new node, basically I'm allocating memory for a new structure variable of type node, and the pointer to which is new underscore node. And now to this newly created structure variable, its value I am assigning as the value to be inserted, op1. Now if the after node is double equal to null, what does this mean? When will after node be null? This will be in this particular condition. When temp was null, after node will also become null. So if after node is double equal to null, um sorry, I forgot. So I also have a return statement here. Yeah. So this is a kind of a trick actually. Um, what I'm doing here is something like this. I gave you two options, right? You can either add it to the beginning or in the middle. So if you want it to be added at the beginning, the value of after node should be null, right? Because there is really no node which is prior to the head. So I initialize after node with null, and if I do find such a node within the linked list, so this part is catering to the second type of insertion, and this code is for the first type of insertion where I want to add something right at the beginning. So here is what is happening. If the head is currently, if you want to insert the value at the head itself, then this after node part would be null. And by the way, it would be null, it should be null here as well, but because I have written a return statement, it will never reach here. That is the idea. Line number 61 will only be executed if temp is not null. This is the idea, right? Otherwise line number 61 will not be executed. So the only case in which I am currently at line number 67 and after node is also null will be the case when we actually did not go inside this if condition at all. So I can be absolutely sure at this point of time that if after node is null, I am basically supposed to insert this node at the beginning of the list. So in this case, what I am doing is I'm basically saying new node arrow next equals head and head equals new node. So what am I doing here? I am now adding the node to the beginning of the linked list. How am I adding this? The current node, the current first node of the list is now being pointed to by this particular node's next pointer, and then I actually change the head to point to the newly added node. Is this part clear? If you guys have any queries on this, please ask now. Let me check the chats also. So is this part clear, guys? And can you understand what exactly happened till here? Any doubts? Okay, Karthik, what part didn't you understand?
So this part, so new node is equal to next, and head
Oh
is
yeah,
equal.
this part. Let me use up um, a text editor for now, or let me use some image from Google. Insert at the list. This one. Let me stop sharing and screen tab. Okay, so this is. Can you guys see what? Can you see this particular image and my mouse pointer?
Yes, sir.
Huh. So as of now, just forget that there is something like E. Okay. Just imagine in my linked list, I only have A, B, C, and D, right? And head is pointing to A, right? Because that is the first node on my in my linked list. If I want to add something to the beginning of the list, what I say is, first of all, I will create a new node, and let us say the data value for this node is E. Then what I'm trying to do is its next pointer that starts pointing to my current head like this. Okay, and then I start pointing head to this node. So now what will happen, if you imagine, basically now E has been inserted at the beginning of my list because head is pointing here. So E is the first node in the list, and if you start following the next pointers, from E you go to A, from A you go to B, from B you go to C, and from C you go to D, and then it is a null, right? So what was essentially a 4 node list prior to the insertion has now become a 5 node list. Does it make sense now?
Yes, sir.
Basically I'm changing the head pointer to point to the new node, the newly added node, and the next pointer now points to the previous head. Okay guys, is it clear now?
Yes, thank you.
Yeah. So that part of the code that we just saw, where is it? Stop. Let me share it again. Hmm. So these line number 70 and line number 71 are basically doing the same thing that we just saw in that picture. Okay. So this is the case when I'm adding something at the beginning of the linked list. If I'm adding something at the middle of the linked list, then it's basically the same, but what is now happening is something like this. This new node, it has to be inserted in in between, right? So in fact, let me just use another
So your
image
screen
from.
is not visible.
Oh, screen is not visible. Oh, sorry.
Yes,
Um,
yes.
Let me actually anyhow show you first an example, and then we'll go back to that node in a linked list. Let me show you some example, then you can understand. Insert node in linked list. Huh, this one. Mm, can you see this particular tab now?
Sir, I don't think you're sharing your screen.
Hello?
Sir, it says written you are starting to share content.
Is my internet connection poor? Let me just check. It's fine. Can you see my screen, guys?
Sir,
No?
No, sir, I cannot see.
No, sir.
So what is the issue?
So it's just written you are starting to share content.
Yeah, here it shows me that the this content is being shared. Uh,
Now sir, it's visible.
it's visible. Okay.
Yes, sir.
So now you can see the mouse pointer as well.
Yes, sir.
Yes, sir,
Yes,
now
sir.
it is
Great,
fine.
great. So now let us assume that we have to insert E not at the beginning, but right after B. Okay. So in our code, after node is currently pointing to B. Okay. After node is currently pointing to B, and the new node I have already created. I have put the values in this. Now what I have to do is something like this. The current next of B is pointing to C. So I have to break this link. I'll have to make this current next pointing to E, and and this pointer, whatever was here, that has to be copied here, right? So that what happens is When I traverse my linked list, I go from A to B, B to E, and E to C. Okay, so then it becomes the fifth node in the linked list. Is it clear? The idea is clear. Whatever is whatever is the value here, I need to copy it here and change this value to point to here. Is this part clear? And then we'll go to code. If this part is clear, then let's go to code. Can you guys see the screen?
Yes, sir.
Okay.
It's visible to me, sir.
I hope it should be visible to all if it is visible to one. Uh, so this is the point that you understand what is after node. After node is basically B. New node is basically E. What I'm saying is in the new nodes next, I need to point to C now, right? And the after nodes next is currently C. So then this C gets copied into E's next, and B's next starts pointing to E. Okay, is this part clear? Any doubts on this? Any queries? Okay, so this makes sense, right? Basically what I am trying to do is I'm trying to insert something in between two nodes, and the way to do that is I just change certain pointers. Okay, B's next start pointing to E, and whatever was currently stored as B's next, that gets stored into E's next, right? So that that chain continues. That is the idea. So now this is the complete insertion part. Any doubts in the complete insertion code? If you have any doubts, please ask now. Is it clear, guys, to everyone? How exactly are we doing insertion? There are two cases: insertion at the beginning, insertion in the middle, and this is basically how it works. Okay, shall we move to deletion then? Okay, so now comes the deletion part. I think I had made some changes. Let me just check up. I don't remember. I think I did make some changes in this code. I don't remember what it was, but I mean, I think we discussed it during the class, and someone pointed out there is some bug.
Yes,
Uh,
in the if part,
in the if part. Just a
so,
minute.
so we had to use one temporary variable also.
Yes. I got it. Just a minute. I'll copy it from my Google Drive program and put it here. This one. I think this is what it was, right? Okay. Thank you. I just opened up the code, and yeah. So now this will not be a confusing thing for you guys. Okay, so let's start with the deletion part now. Okay, now the first thing that I need for deleting something from the linked list is the linked list itself, right? That if the linked list is empty, I cannot delete anything from it, right? So that is the first thing that I check. If head is null, I simply say linked list is empty. You cannot do any deletion on this. Otherwise, I ask for the value to be deleted. And by the way, I forgot to repeat this, that whenever you do insertions and deletions in a linked list, um, this code basically assumes that there are no duplicates. Okay, so the same value is not appearing multiple times in the list. If they are going to appear in the list multiple times, then you need some kind of a policy. You decide what will you do with it, right? If I, for example, have two versions of B, okay, and you say please insert E after B, then what should I do, right? The easiest thing to do is that, okay, I'll insert E after the first instance of B, that is it. Or I can say I will insert E after every instance of B, okay? Or I'll insert E after the last instance of B, whatever it is, right? It is a policy. You have to come up with your own policy. So here I am assuming that there are no duplicates, and if there are any duplicates, basically we only care for the first instance of a value starting from the head pointer, right? So that is the same thing here. I am asking what value do you want me to delete, and how, again, what will I have to do is, there are two cases here, right? Um, if the head itself is containing the value that is to be deleted, then I have to do something else. What I'll tell you, and if this value is somewhere after head, then the code is different. Okay, so let us first check up what is the head thing, and again let me find out an image on Google so that you understand the concept first. Uh, delete head from linked list. Is there a good image that I can use? Mm, Maybe this one, but just a minute. Delete head. Okay, maybe this one can help me. So let me show you this image first. Can you guys see this image? This one?
Yes, sir.
Good. So this is the idea that basically, okay, I'm not sure this is the right image. Just a minute. Insertion head to be deleted. Yes, kind of this. So this is my current head, okay, and this node is I want to delete this, right? So actual deletion is very simple. All I have to do is I have to take this head to the next pointer of this current head, right? If head starts pointing here, this node is essentially deleted from the linked list. There is no way for me to reach this node. Again, it is the same as deleting a value from array. You remember, right? That in the array also we used to say, the only thing I'm going to do is I'm going to ignore this value. So the same thing is going to happen here, that if I actually take head to this node, now I cannot reach this node, so this is as good as good as dead for me, right? So the same thing I'm going to do, I'm going to let the head go here, and then the rest of the linked list remains exactly the same. There's just one change that we usually do before we make this change, before we make head as head next. We keep a temporary pointer to this node so that we can free the memory. Because remember, we all all these nodes were created using malloc, so the good practice is to free it explicitly using free. But other than that, it is very simple. All I have to do is head equals head next kind of thing, right? Head arrow next, and then head gets deleted. So now let's go back to the code. Can you guys see the screen?
Yes, sir.
Good. uh, so then this is exactly what I'm saying. Basically, first I'm taking a temporary pointer to head, then I'm doing head equal to head next, and then I'm doing free temp. Okay. um, any queries in this? It is very simple, but still, any queries? No. Okay, so let's move to the second part. And in fact, let me also first pick up a nice image. Delete node from linked list. This is good. See, teaching all this in a classroom setting would have been so easy. I could have shown all these things to you on a board. But here I have to share, unshare. Anyhow, so this is the idea, guys. That now I'm supposed to delete C from this list. Okay. So again, the first thing I have to do is I need to traverse from the beginning and keep on moving ahead. I need a pointer to B actually, right? Just like insertion, when I had to do insertion, I had to find the previous node. Even with deletion, I have to find the previous node, the node which is to be deleted. I have to have a pointer which which is pointing to the node just preceding the current node, the node to be deleted. Once I have this, okay, then all I have to do is just change this next pointer. Okay, now instead of pointing to C, I change it to point to D. So basically, B's next becomes C's next. That is it. Okay, and then if I have a temporary variable pointing to C, I can free the temporary variable. Is this part clear? And then we'll go to code. The idea is I have to find a node preceding the node to be deleted, and then the next pointer of this simply starts pointing to the next pointer of the current to be deleted node, and then I free the node. This is the deletion process. If this is clear, I'll move to code. Okay. Again, can you see the screen?
Yes, sir.
Uh, okay, so it, not everyone could see. Is
Now
it
it's
the issue?
visible.
It's visible. Okay. So now this is what we are going to do in this else part. Okay. So the first part again is traversing the linked list and finding out the right node. So this is what is going to happen here. Um, Instead, so you understand that basically I have to be one step behind, as in if I want to delete C, I also need a handle, a pointer to B, right? Even though the value I have to check is C's value, right? I have to check I have to find the node which is to be deleted, but I also need to point to the node just before this as well, because I have to manipulate the pointers. So here this traversal loop is slightly different. Okay, instead of checking temp value, I am checking temp next value. Okay, so when will this loop end? It will. So let us say my temp is currently B, it is pointing to B. Temp next will be pointing to C, and temp next value will basically be C. That is the idea. Okay, and the op is basically the value I am supposed to delete. So what is the advantage of this one? We can call it a look ahead kind of a thing, right? So I have to look ahead by one node here. Okay, and why am I doing this look ahead thing? Because I need a handle one step back. If I want to delete C, I need to have a pointer that is pointing to B. So that is why I'm using this trick, that here this condition is that temp next value, you should stop at that point itself. If the value of the next node is equal to the value that I am supposed to delete, then please stop there. Okay, that is the idea. And once I stop there, so here after when this loop ends, temp will actually be pointing to B, for example, and not C. Okay, if we go back to the example, so then what happens, there is a condition where I do not find that value at all, right? So when will that happen? And in that case, it will be the case when temp is pointing to the last node in the list, and and we have not yet found the value to be deleted. So in this case, I just print out the error. I say this particular value is not there in the list at all. So the deletion has failed, and then there's a return statement as well. Otherwise, what I say is the previous node is temp, right? So basically, temp, as I said, is B. So now previous node points to B. Um, temp equals temp next, and then this is basically, the now temp becomes the node becomes C, right? The node to be deleted, and then previous node next equals temp next. So this is that point, right? Basically, b's uh, b's next now points to c's next. That is the idea, the same thing that we saw in the image. So this is that part, and then I am finally deleting c here. Any queries on this, please ask.
Sir,
Yeah.
sir, if the node to be deleted was the last element in the linked list, then
Mhm.
won't it throw an error?
No. So this is the idea. Let us take up that example. I mean, let me in fact reshare that screen. Mm, sorry, did I start my video? Okay, let me stop it. This is the one. Uh, huh. So let us get to this one. Let us say I want to delete D. Okay. Then how do I start? I start from head, right? And I say, what is the value in the next node? That is P. Okay. And that is why, the head condition I have actually checked previously, right? Because in this loop, the loop that we have written, the look ahead loop, we will never check the value at head, right? We will always start checking the values from the second node onwards in that particular loop, the loop that we just saw, temp next value loop. So that is why we have to write an if condition for the head straight away. So that we have just checked, what if the value to be deleted is the head value? If it is not the head value, then what I do is I start from here. In the beginning, my temp is here. I checked what is temp's next. This is temp's next and the value B. Okay, so no, B is not the value I am supposed to delete. I move forward by one. Now temp is pointing here. I check, okay, what is the value at temp's next? This is C. So C is also not the value. I move the temp here. Temp comes here. Remember, I have to delete D. Okay. So now I say, what is the value that is at the next node? D. Oh yes, D is the value that I am supposed to delete. So here my loop breaks. So my temp is currently pointing to C. Does it make sense? I am going to stop one step before the node that I am supposed to delete. Okay, so if the last value of the linked list is to be deleted, I will stop one step back at this node. And if the list has only single node within this, if there is a single node within this list, then this will be caught in the if condition itself, because that will be the head node itself. Does that make sense?
Yes, sir. Thank you.
Okay, so let's go back to the code. Screen application here. Okay, any queries on this? So can you now understand the yeah, can you see my screen? You guys, right? You can see my screen now? This is, I have to ask it every time.
Yes, yes.
Okay. So any questions on the deletion part in general? Okay. So I hope the deletion part is clear too. So these are the two things associated with the linked list that we discussed. Um, we have around 5 more minutes, so I don't think we'll be able to start looking at another program. But if you have any other code related questions, you can ask. Anything related to code, you can ask. We have around 5 minutes of time. No queries related to code.
So we could have that poll, I guess.
Yes. Who's the poll creator? I'll make you the host.
Uttaran.
Uttaran, are you there? Uttaran? Okay, Pranav
I guess
has
I'm not here.
has put you in a bad position, Uttaran. So who else is using the desktop app? Nehal, you were using, na?
Yes, sir. Yes, sir.
So I'll first make you the co-host, I would say, and then let me check if that enables. Make co-host. Now check if you get the link. Okay, Pranav has also sent some link instructions. So what are we polling for basically, guys? So we are essentially asking you guys to pick up a day in the next weekend, not the coming weekend. In the next weekend, either Saturday or Sunday. Um, I wish to have a guest lecturer give you a lecture. It is, as I said, it is not mandatory to attend this, so you can only give your opinion on the poll if you wish to attend it. Otherwise, it's perfectly fine.
So I think Nehal needs host.
So Nihal, you are the host now,
Yes, sir. I'll check again.
and make me the host before the meeting ends, so
Yes, sir.
that
Yes.
the recording thing doesn't have an issue.
So still, it's not there. Like in manage panels, I'm supposed to see polling, but I only see participants and chat.
Pranav,
So we had tried this the other day, like in a private room. I don't know, but it was with Uttaran, not me. I don't know.
so Uttaran is the lucky charm. Where is Uttaran?
He's not here.
Okay. Okay, fine, guys. So just Nihal and Uttaran and Pranav, just tell me some date. It's a very simple thing, right? Saturday, Sunday, and any preferred timings that you guys would have. I'll talk to Avnish and I'll try to schedule the lecture. Okay. Um, okay, guys. So I think from my side, this was this. And by the way, you guys are interested in the additional topics in C, or would you guys um would you just guys would you like to have more discussions like this? Do tell me. I have some additional topics to teach. They are C specific. You can check out the syllabus, by the way. That is the last week. I think what would be week 10, 11, something like that. So check out, right? Would you like to know more about C language, or because they are additional topics? If you don't think that we should discuss them, we can leave it. If you want, I can discuss it. So think about it. Do tell me over email what would you like to do. If you're interested, I'll create lectures for that. Otherwise, we'll start with the revision. It's up to you guys. Okay. Okay, guys. Thank you. We are finishing on time today. And thank you. Bye.
Thank you, sir.